Definition of acids and bases. There are two different definitions of acid and bases based on Bronsted-Lowry and Arrhenius. Based on Bronsted-Lowry, he states that acid is any substance that can donate a proton in the form of H+ to other substance. For example, methanoic acid reacts with water or it dissociates in water. This H is donated to water to produce H3O+. The H+ is donated to produce H3O+ and HCOO-. Base is any substance that can accept a proton from other substance. For example, NH3 accepts a proton from H2O to become NH4+ and OH-. Well, Arrhenius states that acid is a substance that has H in its formula and dissociates in water to yield H+. This is HCl. It has H in its formula and dissociates in water to yield H+ and Cl-. Base is a substance that has OH in its formula, for example, NaOH. This is OH in its formula and dissociates in water to yield OH- and Na+. So this is base. In general, acid can exist as positive charge and negative charge or neutral. So acid can be H3O+, H2SO4, HCO3- and NH4+. Base can only exist as negatively charged or neutral. It cannot be positively charged for base. Only negatively charged or neutral. For example, OH-, Cn-, NH3, and H2-. Meanwhile, water is amphoteric. It can be base or it can be acid. Conjugate acid-base pairs. Conjugate acid is a species that remains when a one proton, a H+, has been added to the base. For example, here, this is conjugate acid. This species remain when proton has been added to this base. This is base water. When water is paired with acid, it will be base. When water is paired with base, it will be acid because water is amphoteric. So here, water is paired with acid, so water acts as a base. So this base accepts one H+ and it becomes conjugate acid. While conjugate base is a species that remains when one proton, a H+, has been removed from the acid. This is acid HCO3-. This H+ is removed from the acid and becomes conjugate base CO3(2-). For example here, ethanoic acid dissociates in water to produce CH3COO- and H3O+. So this acid donate H+, becomes conjugate base. This base accept H+ to become conjugate acid. This ethanoic acid is a weak acid. Weak acid dissociate very slightly in water. Means when it dissociate very slightly in water means this acid prefer to be in this form instead of conjugate base form. So it's not preferred to donate the H+, it prefer to stay as the acid because very little of CH3COOH dissociates to produce H3O+. The equilibrium position lies very far to the left, so it prefers to stay in this form instead of becoming conjugate base. So the tendency of CH3COO- to gain a proton is much greater because it prefers to stay in this form. So conjugate base, the ability or the tendency to gain proton is much greater than the ability for acid to lose a proton. Therefore, CH3COOH is a weak acid, CH3COO- is a strong conjugate base. The weaker the acid, the stronger its conjugate base, while the weaker the base, the stronger is its conjugate acid. Lewis definition. Acid is a substance that can accept a pair of electrons to form a covalent bond. The species can be Lewis acid or cations because it prefers to accept electrons, so cations. Molecules with incomplete octet central atom such as BF3, BeCl2. Molecules that have polar multiple bond, not non-polar, polar multiple bond except C double bond C. Molecules with central atom that can expand octet such as PCl3. So phosphorus expanded octet, central atom, so it can be acid. This is Lewis base, this is Lewis acid, this SN, it can be expanded octet, so SnCl4 is a Lewis acid. Lewis base is a substance that can donate a pair of electrons to form a covalent bond. So donate electron, the species are anion, negatively charged, because it wants to donate electron. And then molecules with lone pairs, molecules with non-polar multiple bond. Lewis acid, molecules polar multiple bond. Lewis base, molecule with non-polar multiple bonds such as alkene. This is Lewis base. It has lone pair electron because it can donate a pair of electrons, so it must have lone pair electron to be Lewis base. And this is Lewis acid because this B is incomplete octet. Molecules with incomplete octet, Lewis acid. Strong acid dissociates completely into ions in water, means all the HNO3, all HNO3 dissociate to become H3O plus and NO3 minus. So initially there is a concentration of HNO3 and all of HNO3 becomes H3O plus. Final zero concentration of reactant. That's what it means by dissociate completely. No remaining reactant concentration. Dissociate completely into ions in water. We know that Kc expression is product over reactant. So when all becomes a product value is very large. So that's why for strong acid, Kc is extremely large. For example, strong acid, hydrohalic acid, HCl, HBr, Hi, and oxo acid, HNO3 and HClO4. Weak acid dissociate very slightly into ions in water, means not all HCN will be converted to H3O plus and Cn minus. Only a very small amount of HCN will be converted to H3O plus and Cn minus. Means this product concentration will be very small. We know that Kc expression is product over reactant. When the concentration of the products is very small, so Kc will be very small. Example of weak acid is hydrohalic acid HF, acids in which H not bonded to O or H not bonded to halogen, HCN and H2S. Oxo acids, HClO, HNO2, H3PO4, and organic acid R can be any carbon and or anything, bonded to COOH. This is organic acid. Strong base dissociates completely into ions in water, so the Kc is extremely large, means O and AOH will be converted to Na plus and OH minus. For example, M2O or MOH. M is a group 1 metal, such as Li and AK, Rb, and Cs. While weak base dissociates very slightly into ions in water, so the Kc is very small, means not all NH3 will be converted to NH4 plus and OH minus. Only a very small amount of NH3 will be converted to NH4 plus and OH minus. Example of weak bases or NH3 amine are NH2, R2NH, R3N, such as all these are CH3CH2, CH32, and hydrazine N2H4.